I'm Zwar, I'm based here in Laura. Run AgTech services since about 2014. So we do soil sampling and mapping services, as well as guidance, sales and service as well, which is starting to keep us pretty busy. So a lot of what we do is grid sampling. So the others sort of touched on grid sampling and how that sort of works. So this field here, this paddock we've actually done one sample every half a hectare, so two samples per hectare. So it's a 70 by 70 metre grid, so it's a 100 hectare paddock with 200 samples taken. Again, we tailor our sampling to do, depending on what the customer wants and what they want to know. We can do different things at different depths, and as complicated as you want down to as simple as you want, sort of thing. So this one, we just did a pH map. So each point there we tested for pH and calcium chloride. So you can see there's a bit of variation. So a lot of the paddock is between 6 and 7.8. So pH is sort of not bad. It doesn't need lime. A lot of it then goes down to 5.5 to 6, and some there down to between 4.5 to 5 in the lower areas. So you can see that the whole paddock obviously doesn't need lime, but there's some there that can benefit from an application. So from the point map, we create, I call it a contour map. That will give you, basically it's a bit like your yield map style of map. Obviously you can see different zones and what's happening in each area of that field. And then you can use that map to create prescriptions. So lime's the obvious one. I've actually got a customer who does a snail bait application off of a pH map. So he puts his snail bait on where he's got higher pH, where he's got calcium in the ground. And some guys use it as part of their phosphorus prescription as well. So where they might have a higher pH, they might put a higher phosphorus rate to try and counteract for a high PBI in those areas. So this customer just did a pretty straightforward lime application. So over the 115 hectares, he's going to average just shy of 1.5 tonne over the whole paddock, but he's got some areas here, so he didn't actually put it all on in 1 year, but there's light blue areas are 6.5 tonne up to 8 tonne in that dark blue spot, 4.5 tonne in the green, and 2.2 tonne in the yellow. So sort of putting what's needed where it's needed, more so than just having a stab in the dark and spreading it across the whole paddock. Zone sampling. So again, just rather than grid sampling, taking one every hectare. This here is, so the background image there is a NDVI, so that's an August wheat crop. So you can use basically any background image, so whether it be a yield map, a protein map, EM38, or a satellite image like that. Something that picks up some variability, and then can go into each zone and test it for whatever your desired outcome is. So this customer had an inkling he had some varying phosphorus levels. So we loaded up some satellite pictures, which we got them through Jess. Then in each zone we pulled a 0 to 15 core and did a DGT phosphorus. So you can see where his crop here is thriving. He's got this beautiful blue area in his map, and the crop was 18 inches high and as thick, and I felt bad driving through it. So he's got a DGT phosphorus of up to 200, and it was sort of loving life there, and it was a pretty good year. Right down to, so in this red area, and visually you can see this crop was struggling, it was spindly and wasn't overly happy, and you can see that phosphorus levels there were quite low, so we had a pretty good, it sort of corresponded very well with the following year. After harvest, that had a variable rate he put on it. I think it was biosolids he put on there to try and bring those phosphorus levels up in those low areas, because it was identified as being a limiting factor.
So what part of the world was that?
That's that one.
Okay.
So that's Bill Catford's. That's his airstrip there. So
Yeah, right.
kind of flying into Appler, you can land there.
Probably.
EM38, so the others touched on that a bit before, so I won't go into the science of it, it's more about how we collect it. So basically we drive up and back with a, or we use a gator, we just drive up and back and it just tows along behind it, takes a reading every second basically, we don't have to stop. So that's done on the go, we just drive up and back every 36 metres or something else if you so desire. And then so you can see there, you can sort of see it lines up with the Google Earth image, so you can see there's a sandhill through there, you can see the lighter colour in the background, as opposed to tail standing here, some heavier ground through here, sort of thing. Then from that, we can either build a contour map like we did with the pH map. The other sort of maps we use is a grid map. A grid map we use if we're calculating an application and it's got lots of different inputs in it. So for argument's sake, if we were doing a P replacement map but we had a grid sampled phosphorus map and we had the yield map, we could say we were doing P replacement on the yield, but if the phosphorus is low, we'll do double replacement. So what a grid map does is it'll cut it up into little squares and it'll say, well, that square yielded 1 tonne and the phosphorus is this, 25 parts per million, and you can have all of those inputs in that one square, which we can then put into a formula. That sort of makes sense. So rather than having a big zone that it's calculating, it'll actually do it square by square based on multiple inputs to make a formula. That sort of makes sense.
Can you put the grid map into a machine, or do you have to then, once you've done all that, do you then finally convert it to a contour, or not?
No, you can put the grid map into a machine.
You can.
Yeah, so you'd probably set a small enough grid that it would not give you big ugly square chunks as you're doing variable rate. Like that would be like a 35 metre grid, so basically one swath width of the spreader sort of thing, which that's going to work just as well as a contour map.
You need to convert that to a some sort of amendment or something if you want it to be a VR map.
That's going to have to be a prescription.
Yeah, if you chuck it on just to do it manually, then that's cool, but yeah.
Yeah, but yeah, we use the grid map to create the prescription because we can do it square by square with multiple inputs in, multiple data points, multiple data layers in each square, sort of thing. Yeah. Because all of this zone won't necessarily have the same, like if that was a yield map for argument's sake, if that there yielded 1 tonne, not all of that red zone is necessarily going to have the underlying phosphorus map goes with it, so half of that might have a low phosphorus and half will have a high.
Yeah.
So if we make it into a grid, it'll actually calculate square by square.
Yeah.
That sort of makes sense.
Yeah, no, I wasn't sure if you, once you've did all the calculations, so the replacement plus the capital, once you've worked it all out, if you then converted it into a contour after that to make it, I guess, like a bit easier on the machine or not.
Normally just make the grid small enough that
Yeah,
it's
yeah.
pretty much that anyway. Yep.
I meant to say to where I've started like now with the EM map, so say that was an EM map on the bottom, which I think it is.
It is, yep.
I actually pull the raw, all that smoothed obviously makes it nice to view, but for every point you record it looks around it to interpret what the points are, which is exactly what you're getting at there. So with the cores, I've started now a bit more of a specific process where I have a smooth map, but I have exactly where you've gone over the top, and I actually place the core where you've driven. so it's not in a smooth,
Oh yeah,
it's not between,
Yep.
so, which is usually like, what, a spray track or something like that, 36 metres? Yeah, so
Yep.
try to put it not on the spray track, but within
yeah,
curve where you've driven. So
Yep.
it's not in a guesswork zone, I guess.
cool.
Everything's taken in swaths, I guess, with those sorts of
Yeah.
maps.
Not necessarily relevant to everyone, but we do clay depth maps based on EM. Out of each EM zone, so what we've done here is we've done a clay depth, EC, and a pH reading. So we can see if we've got something that's really high EC, we're going to be bringing up salts if they go and delve it, or something like that. Again, we'll do the tests that you tell us to test. So that's where you talk to your agronomist and work out what you want tested, because we sort of think of ourselves as just a data provider. We're more like the IMVS. They don't tell you what medicine to take, they just tell you what's wrong with you, sort of thing. I don't try and come in and take over from your agronomist, because that's absolutely not my job. But from that we can then build a clay depth map. So again, we've done it as a grid map. I don't know why we did. I'm sure there was a reason. And then we can, the farmer can loads that into his John Deere screen. And, he'll go out to deep rip and he'll go, we're driving across a red area. The sand's a bit deeper. The clay's at 40 centimetres. They'll sink it in a bit deeper, but they won't rip the blue areas because it's clay right to the top and that sort of thing. So when you're paying $500 a hectare for a delver to come across your paddock, that becomes pretty handy. So some economics. Again, we can customise jobs to suit what you're trying to do. Doesn't have to be something that you've just picked off of our price sheet. You don't have to just go, I want that. If you want something done at different depths or whatever, that can all be done too. That's a bit hard to read, but basically with the services we do, you can spend anything from $7 for a pH map up to $35 for a dual depth sample down to 600 mil, so 2 samples out of a core down to 600 mil every hectare for pH, P&K up to $35 a hectare, which gets a bit pricey. I'm yet to get anyone to do that. This farm here, so this is down at Huddleston. So that block there's a total of 1,502 hectares in those colours there. And of that, 712 of it had a pH of less than 6. So we assumed that lime was $30 a tonne delivered on farm. It's probably gone up a bit now. And another $5 a tonne to spread it. So if he decided he's just going to go and spread 3 tonne on the whole place, and when he give her a blanket rate, it would have cost him close to 160 grand to do that. If he was only going to spread half of it at 3 tonne, or the 712 hectares that needed it, was only going to cost him 75 grand, which is still a fair chunk of cash. So if we assume that 712 hectares had an average pH of 5, then a wheat crop with a 3 tonne potential is going to lose 400 kilos of potential production just because of acidification. Those figures are from PIRSA. So at $300 a tonne, that's a loss of $120 a hectare. So a pH map at $7 a hectare across that whole place, so it costs him 10.5 grand. Spreading costs cost him 75 grand to spread it, so he's up to a total of just over 85 grand to have that mapped and spread. And theoretically, his increase on production, 712 hectares at $120 a hectare, should in theory make him another $85,000 a year. So it should pay for itself. And going back and retesting those paddocks, so 2015, this paddock here was fairly ordinary, had some pretty low pH areas, well basically right through it except for a bit of a strip through the middle. It's had two lime applications on it, and it's brought it up to, so we tested again earlier this year, and pretty significant change there. And I was talking to him last night, he said he's seen a difference in his yield maps, everything's so much more even, especially with his lentil yields, so he thinks it's paying for itself. This customer we also did, again, custom mapping. What we did is we loaded up his lentil yield maps, so the yellow areas is where his lentils perform the worst. What we did is we built a prescription, and as we drove along taking our grid samples, anywhere that we were parked taking a sample in the yellow area, we actually took so we grid sampled at 0 to 10, and in the yellow area actually took a 10 to 20 as well, to compare topsoil versus subsoil, to see if this topsoil might look like it's all happy, but if the subsoil is still acidic, you've got to put another application of lime on that. So it's his subsoil. You can't actually read the numbers there, but there's a couple of spots here that were okay. But this area, this area up through here, which is where these samples are, you've still got a acid subsoil there, so that's going to get another dose of lime again. Just in those areas where his lentils aren't performing and he's got pH issues at depth. Co-LP grid mapping. Generally when we do a co-LP map, we'll do a pH map with it, and then we can calculate a PBI, hopefully based on, and relate it back to the pH, so we've sort of got that as a benchmark. But, what this customer did is, well, you can see he's got some, sorry, I'm jumping ahead, got some pretty low phosphorus here in this area, and a bit up here. Red's slightly better, there's a couple of good spots, a bit of a good corner down there, so it's sort of fairly variable. And from there we created a prescription, so I got a formula off of this fella's agronomist. This is over in Victoria. And basically he wanted to build his capital P, so he used a single superphosphate, and his target co-LP was to get it all to 25 with a minimum of 35 kilos applied, regardless of the phosphorus map, but he didn't want to put on more than 180 kilos in the pass as well. So I used the formula his agronomist had sent me. We put in that we wanted a minimum of 30, maximum of 180. And this is a map that's spat out, so you can see these areas here that were low in P are going to get a pretty big dose. This area here that had sufficient co-LP, it's just going to put 30 kilos on as a base. And that was more so for the sulphur content of the superphosphate rather than the phosphorus itself, so that it wasn't entirely missing out. Again, Beth said it before, there's more than one way to make a phosphorus prescription, and talk to your agronomist about what suits your system, because everyone's going to have a different scenario of what they're trying to do and what they're trying to achieve. That customer then, at seeding time, still did his blanket rate over the top as well, sort of thing. So that application was purely just to build those low areas up. It wasn't necessarily to feed that crop for that year as such. The other thing we do a lot of is guidance line management. So we map in paddocks for guys, mapping their boundaries so they can pull in and get auto steer and steer them around without hitting the fence most of the time. The big thing with AB lines, make sure you back them up. Have a master file that's got all of your lines on it, and back it up, put it in the cloud, put it on a USB and give it to someone else. Just bloody don't lose it, because one day you ring me and go, well, my screen's died, and I'll go, oh, plug your USB in and load your lines back on, you go, I haven't got them. And then you've got to start again. So yeah, spend the time and map it in once and do it properly. So you can throw your guidance system in your ute and there's this next wayline converter tool. So it's made by a German company called Next Farming. So there's a link there, and you can actually go on there and load your lines in, select what machine you want to spit it out to, and it'll spit them back out. So if you had a Trimble system and you had just bought a TopCon system, you can actually, you can do it, or I can do it, or whatever. You load your lines in, click, we're going from Trimble to TopCon, and it spits them back out, and you're good to go. It's actually isn't that easy. ISO compatible machines, so with ISO bus machines, we're now getting into task data, which is basically an ISO data format. So some screens now, the later ones, we can actually pull your AB lines and everything out of one brand screen straight into another one, and it will just work. Probably a bit limited yet, but I have seen it work with a couple of screens, and it's pretty handy not having to go through a converter tool, go and remap your paddocks in. And surprise, surprise, John Deere screens are the hardest ones to cooperate with. John Deere use a different heading calculation, so we can actually convert them and put them into a John Deere screen, but they'll actually be slightly in the wrong direction by a couple of degrees. So over a paddock a kilometre long, by the time you get to the other end of your paddock, you're probably going to be out by a foot or two, which that's just the nature of John Deere stuff, unfortunately. Any questions?